This is Physics for Grade 10. Produced by Tigray Education Bureau. Transmitted by Dimtsi Weyane Tigray National and FM radio satellites and social media. And also FM Maqala 104.4.
Hello, students. Welcome to today's lesson. Today's lesson is electromagnetic induction. Before we learn electromagnetic induction, let me remind you the previous lesson, what you learned. In the previous lesson, I hope you have discussed about electric motor, moving coil in galvanometer, magnetic flux. Let me remind you the main points of electric motor. Electric motor is a device that converts electrical energy into mechanical energy. Electric motor operates in a system of rotation of current carry loop in a magnetic field. Electric motor is a magnet, rotating coil or armature, slip ring, commutator, brush, source of electrical energy, and switch. Students, you have learned this point from the previous lesson. Today, we will learn about electromagnetic induction. Electromagnetic induction is the process of generating current by the relative motion between wire and magnetic field. Electromagnetic induction is the production of voltage across a conductor moving through a stationary magnetic field. Electromagnetic induction is known as dynamo effect. Electromagnetic induction is one of the ways causing current to flow around a circuit. Electromagnetic induction governs the operation of generators and transformers. It is vital to the propagation of electromagnetic waves such as radio, TV, X-ray, microphone, speakers, and computer disk drivers. Students, it is expected from you to understand the concept of electromagnetic induction. Let us state laws of electromagnetic induction. There are two laws of electromagnetic induction. Those are Faraday's law of electromagnetic induction and Lenz's law of electromagnetic induction. Faraday's law of induction. It states that the size of induced EMF in voltage is proportional to the rate at which the conductor is cutting through flux line. This means to generate a double EMF, the conductor must cut through twice as many flux lines each second. It has another alternative way, is to keep the speed of the conductor the same. But have the lines of flux twice as close together. In other words, double the strength of the magnetic field. Faraday's law of electromagnetic induction states the magnitude of induced EMF is proportional to the rate of change of magnetic flux. Also, he stated about the magnitude of induced current. Students, according to Faraday's law, the magnitude of induced EMF in conductor depends on the following factors. 1. Magnetic field strength. 2. Change of magnetic flux. 3. Number of turns of coil in the conductor. 4. Speed. 5. Change in time. When we put in equation form, induced EMF equals to change of magnetic flux per change of time. Let me pass to the next Lenz's law of electromagnetic induction. Lenz's law of electromagnetic induction states that the direction of induced current is such as to oppose the change that is causing it. To illustrate what it means, whenever a magnet being inserted into solenoid, the north pole of the magnet is coming towards solenoid. Then there is a change that causing the dynamo effect, so that Lenz has stated the above statement. The change that produces induced current or induced EMF is the motion between the magnet and the coil. The two laws can be summarized in equation form. Induced EMF is equal to minus number of turns times change of flux per change of time. The negative sign on the equation is indicated the opposite direction. Students, please see the equation in your textbook, page 143. Again, let me ask you questions. Question number 1. State factors that affect the magnitude of induced EMF in a conductor. Well, the answer is 1. The rate at which conductor is cutting through flux line. 2. A strength of magnetic field. 3. The number of turns if the EMF induced in solenoid. Question number 2. State Lenz's law of electromagnetic induction. Well, the answer is Lenz's law states that the direction of induced current is such as to oppose the change that is causing it. The next topic is inductance. Inductance is a property in an electric circuit where a change in electric current through that circuit induces an EMF that opposes the change in current. When the magnetic flux due to a coil changes, there is an induced EMF in nearby coil. When you send a current through a solenoid, it is not part of the actual circuit, but the magnetic field associated with electric current following around the coil. If iron core is placed in a coil, the strength of a magnetic field increase. This means it has a contribution of a strength of induced EMF and induced current. There are two types of inductance. Self-inductance, represented by capital L, mutual inductance, represented by capital M. Students, let us see one by one the types of inductance. Self-inductance is expressed in the induced EMF in terms of current in a circuit rather than a magnetic flux through it. In self-inductance, if no magnetic material is present, the magnetic field is produced by coil and flux line. Another meaning, self-inductance is the process of producing an induced EMF on a coil itself due to change in its own current. Self-inductance is dependent on its size and shape of the coil. Self-inductance is the ratio of induced EMF produced in a circuit by self-inductance to the rate of change of current producing it. Induced EMF, which is equals to self-inductance times change of current per change of time. Student, there is an equation for self-inductance in your textbook, page 146, as well as a graphic demonstration in your textbook, page 147. By observing the graph, you can understand the idea of self-inductance in terms of battery, inductor, and resistor. In self-inductance, as the switch is closed, current starts flowing. It causes a change in a magnetic field, which in its turn causes a change in flux. The change in flux again causes an induced EMF to develop in the coil itself. When the current is turned on at time t equals to 0, it then raises to its final value of V over R in the form of an inverted exponential curve that builds up of charge as a capacitor fell up through a resistor. With a capacitor, the time constant of the circuit was given by CR and represented the time taken for the curve to raise about 63% of final value. Students, we have an assignment that show the equation of time constant by yourself in page 147, T, which is equals to CR. Mutual inductance. When the current in one circuit is changing, its variable magnetic field cuts through the other circuit and induces a voltage on the other circuit. The faster the current in one circuit changes, the greater EMF induced in the other. This linkage between the two circuits is described as mutual inductance. Mutual inductance will be small if the two circuits are well spaced apart. Mutual inductance will be large if a coil in one circuit is wound round a coil in the other circuit. Mutual inductance is the ratio of electromagnetic force in a circuit to the corresponding change of current in a neighboring circuit. Mutual inductance in a pair of circuits is defined by electromagnetic force induced in one circuit equals to mutual inductance times rate of change of current in the other circuit. Mutual inductance in pair of circuits is dependent on their size, shape, and relative position. The equation of mutual inductance induced EMF, which equals to mutual inductance capital M times change of I2 per change of time. Students, in a page 147, there is an activity. Will an activity worked example? Please see that example and done by yourself. A student, let me ask you questions. Question number 1. What are the difference between self-inductance and mutual inductance? Well, a student, if you answer in the following way, you are correct. Self-inductance occurs when a current is first switched on in a coil and build-up of magnetic flux, induced voltage in the coil, oppose the battery in the circuit. Mutual inductance occurs when a changing current in one coil induces a voltage in the nearby coil. Question number 2. Define inductance. Well, students, if you answer on the following way, you are correct. Inductance is defined as the property in an electric current where a change in the electric current through that circuit induces EMF that oppose the change in current. Students, we have a reading assignment from your textbook, page 147 up to 148, because it requires a graphic demonstration. Students, let's discuss how transformer work. What is a transformer? Transformer is a device used to charge from a source. Transformer is a device that transfers electrical energy from one circuit to another with a change of voltage. Transformer works using laminated iron core. The iron core acting as a magnet that links the two circuits electrically quite separated. The first circuit magnetizes it and generates by dynamo effect. Second circuit detects the arrival of magnet. Therefore, due to this given point above, how transformer works. The iron core of transformer is usually in the shape of closed ring, named as input winding or primary coil, output winding or secondary coil. Students, pay attention. There is an assignment. 1. Read the topic from page 142 up to 152. 2. Do all the activity within the chapter. This is enough for today. Bye.